Hi YouTube, Tim Unkert here. In this video we're going to solve some quadratics by completing the square, and stay tuned to the end of the video because we're going to derive the quadratic formula by completing the square. So let's take a look at problem 1. We have got x squared plus 6x plus 2. Our first step is we want to move the 2 over, so we're going to subtract 2 from both sides, and we're going to rewrite this as x squared plus 6x equals negative 2. Our next step is to take half of the number in front of x, so half of this coefficient, and square it. So I'm going to add 3 squared to both sides. Okay, so on this side we're going to get x squared plus 6x plus 9, and that's going to equal negative 2 plus 9. So on the right hand side we get just 7. On the left hand side we have here, what we have is a perfect square trinomial. So this is going to factor into a binomial squared. And in this case it factors into x plus 3 squared. I do have some videos on factoring on this channel in case you want to take a look at those. Okay, so now we've completed the square. Now we can take the square root of both sides and solve for our two solutions of x. So I'm going to take the square root of both sides here, and I'll get x plus 3 equals plus or minus the square root of 7. Okay, so now we've got to find our two solutions. We're going to subtract 3 from both sides. And so our two solutions are going to be x equals negative 3 plus the square root of 7, and x equals negative 3 minus the square root of 7. Okay, so we're done with that one. Let's take a look at this one. So again, we're solving by completing the square. We've got 2x squared plus 5x minus 4 equals 0. So I'm going to add 4 to both sides. And I'm going to get 2x squared plus 5x equals 4. Now, our next step is to divide by the number in front of x squared. You can do that first and then just move the number over. It doesn't really matter. So we're going to divide by 2 here. We divide everything by 2. And we'll get x squared plus 5 halves x equals 2. So now what I'm going to do is I'm going to take half of 5 halves, so 5 fourths, and square it and add that to both sides. So plus 5 fourths squared, and we'll add that to both sides. Okay, so on the right hand side I'm going to get 2, and I'm going to write 2 as 2 over 1 because we're going to have to find a common denominator in a moment here. 2 over 1 plus 25 sixteenths. And then on the left hand side we've got x squared plus 5 halves plus 25 sixteenths. 5 halves x. Okay, now notice here this is a perfect square trinomial, so this is going to factor into x plus 5 fourths squared. And then on the right hand side we've got to get a common denominator, so I'm going to multiply 2 by 16 and 1 by 16. So I'm multiplying by 16 over 16. And so that's going to be it's going to be 2 times 16 is 32 plus 25 is 57. So we got 57 over 16. Okay, so now what we can do is we can take the square root of both sides. And on the left-hand side, we'll just get x plus 5/4. Move this down a little bit. And that's going to equal plus or minus the square root of 57 over 4. Okay, so now we've got to subtract 5/4 from both sides. And we get our two solutions, x equals negative 5/4 plus the square root of 57 over 4, which we can just write all of this over 4 if we want. So we could have negative 5 plus the square root of 57 over 4. And we also get x equals negative 5 over 4 minus the square root of 57 over 4. Okay, so we're done with number 2. All right, let's look at problem 3 here. So same thing, we're going to solve by completing the square. If we want to, we could divide everything by 3 first and then move over. So I've got 5/3 to move over. I'm going to subtract 5/3 from both sides. And 3 divided by 3 is just 1, so I get 1x squared plus 4/3 x, and that's going to equal a negative 5/3. We're going to take half of 4/3 and square it, so that's going to be 4/6 squared. And we'll do the same thing here. 4/6 squared. Okay, so now what we need to do is, well, we've got to do 4/6 squared, so we get x squared plus 4/3 x plus 16 over 36. And that's equal to negative 5/3 plus 16 over 36. Okay, so I want a common denominator on the right-hand side, so I'm going to multiply both the top here by the top and the bottom by 12 to get the denominator of 36. Okay, so we're going to get negative 60 over 36 plus 16, so that's going to be a negative 44 over 36. Okay, on this side, this is a perfect square trinomial, so we can factor this into x plus 4/6 squared. Okay, so now what we want to do is we want to take the square root of both sides. Okay, so we get x plus 4/6 equals plus or minus the square root of negative 44i. Or, I'm getting ahead of myself, of negative 44. We will get an imaginary number out of this. Okay, so, and square root of 36 is not 36. Square root of 36 is 6. Okay, so now what I need to do is I need to subtract 4/6 from both sides. And I'm going to simplify under the radical there. So my solutions will be negative 4 plus you can pull out a 4. This is like, I go over here, this is like negative 4 times 11. If I take negative 4 out of the square root, it becomes 2i. So it's an imaginary number. So because you can't take the square root of a negative number. So this becomes 2i square roots of 11 over 6, which simplifies into negative 2 plus I square roots of 11 over 3. Okay, and we also have x equals negative 4 minus 2i square roots of 11 over 6, which simplifies into negative 2 minus I square roots of 11 over 3. Okay, and we're done with that one. That one resulted in 2 complex numbers for solutions. That means that the graph of the quadratic never crosses the x-axis, in case you're wondering what it looks like graphically. Okay, so let's go up now, and we're going to derive the quadratic formula. So we want to start with a standard equation of a quadratic. So we're going to start with ax squared plus bx plus c, and set that equal to 0. So what I can do is I can move over the c first, or you could divide by a, and we'll get ax squared plus bx equals negative c. We'll divide everything by a. So now we get x squared plus b over a x equals negative c over a. Okay, so what I want to do is I want to take half of b over a and square it and add it to both sides. So I'm going to add b over 2a squared to both sides. We're going to have to maybe just position this just a slight bit different. So I'm going to get x squared plus b over a x plus b squared over 4a squared. And that's going to equal negative c over a plus b squared over 4a squared. Okay, so now what I need to do is I need to get a common denominator here. So what I can do is I can multiply both the top and the bottom by 4a. All right, so we're going to multiply both the top and the bottom by 4a. And if I rearrange the fraction on the right, I'm going to get b squared minus 4ac. Now that I have a common denominator, it's going to be all over 4a squared. And this is a perfect square trinomial on the left. So this is going to factor into x plus b over 2a squared. And now I can take the square root of both sides. And I'm going to get x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over 2a. Now I'm going to subtract b over 2a from both sides. And so when I do that, I get just x equals negative b plus or minus. They both have the same denominator here, so I'm just going to combine this all over 2a. So it's going to be negative b plus or minus b squared minus 4ac. And it's all over 2a. And there you go. We have derived the quadratic formula. Hopefully this video was helpful to you. If it was, please give it a like and subscribe to the channel. Also, if you want to support the channel in another way, I'll leave a link to my Teacher Pay Teacher store in the description, as well as a link to the website for you to check out more great math content. Hope to see you in the next video. Have a great day. Bye.